This is the remainder of section 7.4. It's about interest and also about mental estimation. It's our last section. Here we go. I'm going to cover up the word problem part because I want to just look at that formula with you right now. This formula is for compound interest. Simple interest is a simpler equation, but this is for compound interest. We need to know what every little letter means, and then it won't seem so complicated. P stands for principal. Principal is the amount of money you give someone, like you give the bank and then you want some interest back. 1 is 1. R is the rate the bank is willing to give you, the interest rate the bank is willing to give you. N is the number of times per year the bank looks at your money and accrues interest for you. It's the same as this N. T is the number of years, in other words, the time that you're willing to give your money to the bank. Give your money a longer time in the bank, they'll give you more money back. So let's apply that formula to this first example. If you invest $6,000 at 4% compounded annually for 5 years, how much interest do you get? Let's put all the pieces into this formula that they give us. Principal is how much you're willing to give to the bank. $6,000 is your P, and that always gets multiplied to 1 plus the rate. We can't just throw a percent in there. We have to cha-ching, move the decimal twice. 0.04 is the same as 4%, and it's divided by the number of times per year the bank looks at it. Well, it's going to look at it annually, once a year. We didn't even have to put that 1 there. So up here we're going to say 1 times a year times 5 years. 1 times 5. We could have just written a 5. And now we're going to solve this equation. 6,000 remains. I'd like you to work on the parenthesis first, 1 plus 0.04. And then I'd like you to raise that to the 5th power, 1 times 5, first, and then multiply it by 6,000. So with your calculator, 1.04 to the 5th power is about 1.21665, on and on and on. I rounded it off. You don't want to round it off too soon because then you'll have lost a lot of good information. So I went way out there in my decimal before I rounded it off. And then multiplying those together, you get off the page. Here we go. 7,299 and 92 cents. And we've forgotten what the question is by now, probably. The question was, how much interest do we get? Give the bank $6,000, they'll give you back $7,299. That's if you're willing to give them the money for 5 years at 4% interest. Let's try another one with that same formula. Compound interest formula is in red. Example 2, we're giving them less money, $5,400, but we're getting a better interest rate, 4.5. Doesn't seem like much, but it is. And we're leaving it in for more years, 7 years. And this is important. Semi-annually, the bank will look at your money twice a year and give you interest in July and then give you interest again in December. That's better than annually. So let's write this formula out, dropping in all the pieces we know. P is the principal you're willing to give $5,400 to the bank for a while. 1 stays 1. The rate is 4.5. That's 4.5, but cha-ching, I need to move it twice, so it's 0.045. And it's not once a year, but semi-annually, twice a year. They're willing to look at your money. So you also get a 2 up here. 2 times the 7 years. That's great. That's going to be a 14th power. So let's work on this. I'd like you to do the parentheses first. 1 plus whatever this is cut in half. That's 1.0225. And then raise that to the 14th power before you multiply it by 54. If you multiplied it first, you'd be raising everything to the 14th power, and we only want this part raised to the 14th power. So the parentheses raised to the 14th power is about 1.365483. It goes on and on and on, but I rounded it off, but I waited a good long time before I rounded it. And then you multiply them together, and the answer is they'll give you back $7,373.61, even though you only gave them $5,400. But that's at the end of 7 years. Let's do one more interest problem. I want to show you that when you compound annually, you don't have to put this in the problem. The n is the number of times per year, and annually is just once a year. So we could say that's a 1, doesn't have to be there. That's a 1 times t, it doesn't have to be there. So we're just going to use that formula, but it's the same as this one. So how much money will we give the bank? It doesn't say. So that's what we're missing, the p. So let me write the formula this way. The money we'll get back is $13,000. It's like we have the answer already, but we don't know P, the principal that we're giving the bank. But the rest of the formula is 1 plus rate, 1 plus 0.03. That's the same as 3%. We divide by 1, so we don't have to write it. And then it's 1 times t, or just t, which is 8. So we're going to do parentheses first. That's a math rule. 1.03. We're going to do exponents next. That's a math rule. 1.03 to the 8th power is about 1.26677, on and on and on. But we want to know what p equals. Well, right now it's multiplied to a number, so we're going to divide both sides by that number. And p will equal approximately $10,000. That's how much you'd have to give the bank if you want $13,000 8 years later. Let's do some mental estimations and be done. Mental estimation means I don't want to pull out a calculator. I just want to get pretty close to the answer. So instead of 24%, let's say 25% of 16 is close enough for me. Like you're at the grocery store and you have a 25% discount. We want 25% of 16. Well, 25%, 25 of 100, that's a fourth. I want a fourth of 16. A fourth times 16 is 4. So 24% of 16 is about 4. That's my estimation in my head. It's pretty close. Let's do the next one. 59%, well, that's about 60%. 60 per 100. Of will always mean multiplication. So I want 60% of 120. 60 per 100 times 120. Well, the 0 up here can cross out with a 0 on the bottom. A 0 up here can cross out with a 0 on the bottom, and I just have 12 times 6 over 1. That's 700. I almost missed it. 720. That's not right. It's 12 times 6. I did miss it. It's 72. 72 is about 59% of 120. Next one. 33%. Well, 33%, 33 out of 100, that's about a third. So I'm going to say, what's a third of 12? Well, it's 4. That's the answer. The next two. 2 is what percent of 6? 2 out of 6 is what percent? 2 out of 6. 2 over 6. So I can just divide 2 divided by 6. That's a third. Well, that's 33%, approximately. It's really 33.3 repeating, so it's about 33%. Let's do that again. 40 is what percent of 30? 40 out of 30. 40 is what part of 30? 40 out of 30. The zeros cross out. I'm left with 4/3, which is 1 1/3. That's 1.33 repeating on and on and on. I just need to cha-ching, move the decimal twice. And it's 133 approximately percent.